Today we are going to look at the converse of what we looked at yesterday, which was parallel lines intersected by a transversal. Remember that the converse is made by exchanging or flipping the hypothesis and conclusion. So yesterday we knew that we had parallel lines, and because of that we knew about corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. First one today, corresponding angles. So if you've got corresponding angles and they're congruent, then you know that the two lines that they're on, that are different, are parallel. So if angle 1 is congruent to angle 2, that means that line M is parallel to line N. Next up, we've got alternate interior angles. Remember that they make a Z. When alternate interior angles are congruent, the two lines that are different between them are also parallel. So line M is parallel to line N. Next up, alternate exterior angles. Again, when alternate exterior angles are congruent, the lines that are different between them are parallel, so line M is parallel to line N. And last up, when you have same side interior angles and they add up to 180 degrees, meaning that they are supplementary, then again line M will be parallel to line N. Our next example, we want to name the postulate or theorem that proves that line R and line S are parallel. First off, we're looking at angle 2 being congruent to angle 6. Notice that they're on different sides of the transversal, and they're both in between line R and line S. So this is alternate interior angles. Our next example, we're looking at angle 4 and angle 8 being congruent. So again, they are on different sides of the transversal, but this time they are outside of lines R and S. So they are alternate exterior angles. Our next one, we're looking at angle 7 and angle 6, adding up to 180 degrees. They're on the same side of the transversal, and they're in between them. So these are same side interior angles. And last up, angle 1 and angle 3 are congruent. They are on the same side of the transversal, but one is outside and one is inside the lines R and S. So these are corresponding angles. Our next one, we want to prove that lines L and M are parallel. We're given information about angle 4 and about angle 6. What kind of angle pair are angle 4 and angle 6? They're same side interior angles. And what do we know about same side interior angles? They're supplementary. They add up and equal 180 degrees. So that's exactly what we're going to do. We're going to add these together, set them equal to 180 degrees. So we need to combine our like terms. So 15x plus 30 equals 180. Subtract 30 from both sides. 15x equals 150. Divide by 15 on both sides. And x equals 10. So that is what we were hoping to see. Because those are the same, we know that that means that line L is parallel to line M. Next step, during a race, all members of a rowing team should keep their oars parallel on each side. Angle 1 is 3x plus 13 degrees. Angle 2 is 5x minus 5 degrees. X equals 9. Show that the oars are parallel. So what kind of angle pair are these? Corresponding angles. And what do we know about corresponding angles? They are congruent. So that means that we can set these two equal to each other. So 3x plus 13 equals 5x minus 5. And then what are we going to do? Subtract 3x. So we've got 13 equals 2x minus 5. And what's going to happen next? Add 5. So we've got 18 equals 2x. Then divide by 2. And x equals 9. Which is what we were hoping for. So that means the oars are parallel. Next up, what kind of angle pair do we have? Alternate interior angles. And what do we know about alternate interior angles? They're congruent. So that means we can set these equal to each other. 15x equals 12x plus 17. What are we going to do now? Subtract 12x from both sides. So 3x equals 17. And then divide by 3. So x equals 17 thirds. Our next problem. What kind of angle pair do we have? Same side interior angles. And what do we know about same side interior angles? They add to equal 180 degrees. So that's exactly what we're going to do. We're going to add 9x minus 6 plus 3x plus 18. And it's going to equal 180 degrees. We're going to combine our like terms. So 12x plus 12 equals 180. Subtract 12 from both sides. Then we're going to divide by 12. So x equals 14. Next one, all of these are talking about lines that are perpendicular. So the first one says that if you have two lines that are intersecting each other and these two angles are congruent, the only way that these two angles can be congruent is if they are 90 degrees. And that means that line L and line M are perpendicular. Remember that upside down T means perpendicular. The next one says that when you have parallel lines and a transversal going through it, and one of those lines is perpendicular to that transversal, it means that this other line that's parallel and going through that same transversal is also perpendicular to that transversal. So that means that line P is perpendicular to line Q. Notice those are corresponding angles. And we know that the converse of that is true as well. So if we have right angles on both of our intersections, then that means that line R and line S are parallel because those are corresponding angles. So our next example, we have two lines that are parallel. This angle is perpendicular, or it's right angle. What does that mean that this angle is? It is also a right angle. So 3x minus 2 equals 90. And then add 2 to both sides. So 3x equals 92. Divide by 3. And x equals 92 thirds. And our last example on the notes. Line V is a transversal. Which statement is true? Anytime you have a picture like this, with one line going through several other lines, I need you to find the linear pair that goes with each of these angles. So I need you to find its supplement. So what is 180 minus 70? 110. What's 80 minus, or 180 minus 80? 100. What's 180 minus 110? 70. What's 180 minus 100? 80. Okay, so on all of those, I subtract the number from 180 and get what goes in each of those angles. Then we match up which ones are the same. So, do we have anything else that is 70 and 110? Yeah, line Y. Do we have anything else that's 180? Yeah, line Z. So, which one says that W and Y, lines W and Y are parallel, and lines X and Z are parallel? A.